Hi there, welcome back to this channel. So in this video, I'm going to take you through LU decomposition with Gaussian elimination. In our previous lessons, we dealt with LU decomposition, but we were using the manual method. So we use both the Krauss method and the do-little method. So in this video, I'm going to take my time, take you through the concept where you use Gaussian elimination to express the matrix into the LU form. Please, if this is the first time you've been on this channel, show some love by subscribing to this channel. And don't forget to watch this video to the end. So LU decomposition with Gaussian elimination. So I said when you say LU decomposition, we are decomposing our coefficient matrix A into what? LU form, right? So we just have to express it using either the Krauss or do-little method. Then after you equate each entries, right? But here we are going to use Gaussian elimination. So in Gaussian elimination, I showed you what we call multiplier in our previous videos. So we have the multiplier, then you also have the upper triangular matrix. Upper triangular matrix. So the end goal of Gaussian elimination is to express a matrix into upper triangular matrix. So once you get your upper triangular matrix, that becomes your U. That is this U. So this U that you see here, if you want to use Gaussian elimination to find LU decomposition, then the U here becomes what? Our upper triangular matrix, right? Then the L here, how do we get the L? So the L is simply the negative of what? Multiplier. Negative of multiplier. So without wasting my time, let me give an example so that you see how we can decompose a matrix using the Gaussian elimination method. Okay, so decompose into LU form, and the matrix is given as 25, 5, 1, 64, 8, 1, 1, 4, 4, 12, 1. So how do we decompose this? So we begin by just using exactly the Gaussian elimination. So we start with what? Forward elimination. Forward elimination. Okay. So forward elimination, what do? We need a multiplier. So as we are coming to do the forward elimination, we put our multiplier matrix down. So the multiplier matrix is given as this. We have 1, 0, 0, multiplier 1, 0, multiplier 1, 1, 0, multiplier 2, multiplier 3, 0. So the multiplier 1 is the first multiplier we use in our elimination. Okay, and I said that your row 1 is always a pivot row. So if I want to eliminate row 2, the first entry, I need to take the row 2 over the row 1 as my multiplier. Okay, so to do this, our first elimination, we simply have our first multiplier to be what? 64 over 25, right? Multiplying R1. So this becomes the multiplier here. Is that not it? 64 over 25. And our row operation, is simply equal to our row 2 minus what? 64. So let me solve for the 64 and 25 first. So 64 and 25 is giving us 2.56. Okay, so this is the same as 2.56 what? R1. Okay, so 2.56 R1. Then with this one, our row operation becomes R2 what? Minus 2.56 R1, and all going into what? R2. So after this, we simply rewrite our matrix. You have 25, 5, and 1. Then 64. So you have R2, 64 minus 2.56 R1, which is 25. So you simply punch this on a calculator. 64 minus 2.56 times what? R1, which is 25. And you are getting 0 for the first entry. We do same for 8. So 8 minus 2.56 times what? 5, right? You are getting negative 4.8. Negative 4.8. Then 1 minus what? 2.56. Here is 1. So you get negative 1.56. So the idea is, as you are altering this matrix to an upper triangular matrix, the U will be the U in the LU decomposition. And the multiplier we are carrying along will be what? The multiplier here. So now I know that my first multiplier is 2.56. I'll replace my M1. So we'll have 1, 2.56, 0, 0, 1, 0, M2, M3, 0. Then as I carry on, you see how the process or the transformation works. So the next multiplier is simply going to be what? Here is 144. Here is 12. Here is 1. The next multiplier, I'll just take 144 over my pivot row, which is R1. So I'll have 144 over 25 times R1 as my multiplier. And what is 144 and 25? 144 and 25 is 5.76. Multiplier is what? R1, okay. So the row operation is R3 minus 5.76 R1, all matching to row 3. So once I get this expression, my matrix becomes 25, 5, 1, 0, negative 4.8, negative 1.56. 144 now becomes 144 minus 5.76 times 25, and that is 0. So here becomes 0. Then I move to 12. So I get 12 minus 5.76 multiplying R1, which is what? 5. That is giving me negative 16.8. Then the last one is 1 minus, so that will be 1 minus 5.76 times 1. So obviously that is negative 4.76, right? Then the multiplier, as I said, it was what? 5.76, right? We use the multiplier as what? 5.76 because we, after the division, we had 5.76 here. This is the multiplier, multiplying R1, the multiplier. So I'll change my multiplier matrix 1, 2.56, here becomes 0, 0. I'll have 1, 0. Then M2 is what? 5.76. Then I'm left with M3. So as I'm altering this is going to give me my U and this is going to give me my L. So it's the same thing, it's simultaneous, okay? So let's do the second forward elimination. So here we're going to tackle this inner matrix. So this row now become my pivot matrix and pivot row. So as row 2. So my new multiplier is what? This over this. So negative 16.8 over negative 4.8 multiplying R what? 2. So this expression is my new multiplier. So you just write a fraction, negative 16.8 over negative 4.8, and you are getting 3.5. So this is the same as 3.5 R2. So meaning our new multiplier is 3.5. Then our row operation is R. So this R3, right? So R3 minus what? 3.5 R2, all mapping towards R3. So my matrix will simply be 25, 5, 1, 0, negative 4.8, 1, negative 1.56, 0. Then here, I'm going to get negative 16.8 minus 3.5 times what? Negative 4.8. And that is giving me 0. Nicely. Then the last one be negative 4.76 minus 3.5 times 1 or times negative 1.56. That is giving me 0.7 like this. Whilst my multiplier matrix become 1, 2.56, 5.76. Here is 0, 0, 1, 0. M3 is or 3.50. That's it. So at this point, I have my U and I have my multiplier M. But I said your L is always negative of your multiplier. So therefore, my LU decomposition simply gives the U to be what? 25, 5, 1, 0, negative 4.8, negative 1.56, 0, 0, 0.7. Then my M to this point, this becomes our what? Multiplier, right? So we took the multiplier to be just the quotient of what? The point over the pivot point. So if you take this as your M, then directly your M becomes your what? Your L, okay? So your M directly becomes your M here. So we get L to be equal to M, right? So meaning that our final L decomposition is simply equal to, this becomes our L. So this becomes our L and this becomes our what? U. So whenever you take the multiplier here as at this, you see you can choose to take this as your multiplier. So this would have given us what? Negative 2.56, right? For that reason, if you are to take the L, you have to take negative of that. But here, I will always advise you to take the multiplier to be just the quotient here. Okay, once you take this multiplier, then there is no need to negate your entries here. Okay, so straight away your M becomes your what? Your L straight away. So your L is simply equal to 100 2.56 10 5.76 3.51. Yes, so this is all for this video. Please don't forget to like and share.